Hello everyone, my name is Soma and today we are going to talk about my final term project presentation, which is on precision farming in India using big data analytics. The agenda of the session we have is we'll go through a brief introduction followed by the problem statement, and we try to understand what the path forward is and how technologies such as Internet of Things and big data associated with the opportunities and challenges on big data, how they can potentially help. Then we'll also look at some of the ground realities for this kind of implementation, what the country has in terms of the challenges and issues. So we'll go through that and we'll summarize all of that into a conclusion. Okay. Now, looking at the introduction potentially, right? India is an agriculture-centric economy, which and the farming and agriculture alone contributes to about 18% of the total GDP. And it is also the largest employer in the country in terms of occupation for whoever is working. It contributes to about like 49% of the total workforce. Now, looking at this, the government aims to grow the sector 4% annually, which is like year on year, and that's what the intention of the government is. But however, that would be potentially determined by three things, which is the technologies, globalization, and the markets. And when we talk about markets, is potentially like where you want to sell, where you want to grow, and which market areas that you can tap, and things like that. And of course, the globalization and technologies is something, the latest trends that you want to light towards it. And some of the technologies that we are talking of late, everyone keeps hearing about Internet of Things and big data and various data analytics, right? Marketing science itself is the latest trend of getting into this big data and data analytics. So in those lines, if you look at how we really use these technologies to improve the lives of the farmers in some of the the Asian countries, potentially in India, right? And how you want to actually capture that information, all that is generated from pre-harvest to post-harvesting cycles. Okay, and that is basically to enable the farmers to obtain the minimum selling price for the yield that they produce, and also by providing better inputs and governance in real time for sowing, harvesting, and production of the yield. And this is again in many ways. It is basically to provide them a profit about 25 to 30%, and by providing better inputs and governance, the expense that you incur in producing a certain amount of yield can also be reduced to a greater extent. That's again about 20 to 25% of the expenses can be curtailed with timely information on inputs and governance. Now, use of precision farming technology, right? And not only this increases the productivity, but also integrates the whole supply chain for farmers. So it's not just about or for the profits, but beyond the yield production and all that, there's a lot of other areas that in terms of getting the vendors together and also like expecting or telling the vendors like when your yield is going to come, and create all that logistics and the whole supply chain itself. The entire chain can all be integrated together. Okay. Now, so traditionally in India, the farming methods that are used is crop rotation and subsistence farming, and those are the most commonly used farming methods. Wherein in subsistence farming, you actually produce the amount of quantity which is just enough for the community, or even for the crop rotation. You would actually, it is completely and labor intensive, require huge lands, wherein if you produce in one season, if you produce a certain crop in one side of the estate, then you cannot use it immediately for the next crop. You have to leave it for a certain ideal time and then move on to another place, do the farming, then come back to the original location. So that is like, you rotate the crops between one or two different locations. right? And that also requires like huge amount of space and all that. And also the affordability, right? In terms of if you want to produce an high yield crops, or you want to do that kind of farming, it definitely requires an high capital investment. And also, most of, again, we went through like saying 49% of the workforce, 18% of the GDP. Now, all of this will be successful only if there is enough water, right? And that water usually comes in the form of rainfall, what we call as monsoons. And there's not really enough water to fill those water bodies, right? And even if there are, then the irrigation facilities and the other things such as preserving that water instead of going into the seas or unused, and those kind of facilities, and also the government policies to protect the welfare of these farmers, to provide a minimum selling price or minimum support price. And some of these reasons, the government is unable to actually guarantee what is the minimum selling price that they can do for the farmers, and also the crop failures, and even there are suicidal deaths by the farmers. So all of these are basically the potential causes of distress for the farmers in the Indian community. Right. Now, looking at the path forward, how we really want to handle this issue is that by using the technology, again, all of these listings that you see in terms of like human dimensions, the policies, regulation, and marketing, of course, the policies has to come and enforced by the governments, and also educating the farmers, as well as not just the farmers, but also if you want to use the youth or the graduating workforce and all of them, you have to actually teach them on the farming methods as well as on the technology, right? And that is also part of the education. And there are not too many farming applications or systems that are potentially integrated together, right? And you really need to build those kind of farming systems exclusively, like you have for the manufacturing and what you call as distribution, supply chain, finance. You have ERP solutions similar to that. You really want to do something for the farming systems alone, right? So, but however, the three key things that are going to play a major role is the Internet of Agriculture things and the big data. These two are highlighted in the green color, as well as the Golden Framework. Now, Golden is basically called as Global Open Data for Agriculture and Nutrition. And this is an initiative taken by US and UK governments with the approval in the G8 summit in 2013. Although it was proposed in 2012, the initiation started in 2013. And basically, this type of a framework or this initiative calls for all countries which are having some information related to agriculture and all that to store in this particular database. So that way you really do not duplicate the efforts across multiple countries, and as well as basically to share the information across countries and all that. So like we did for the Human Genome Project, which is genomics and all those things in the early 2000s or the late 90s, which is a common framework of information that was shared across. On similar lines, this is Golden is towards agriculture-related information. So the idea is to collaborate to harness the growing volume of data generated by these new technologies to solve the long-standing problems, right, and to benefit farmers and as well as the health of the consumers. So that is what the Golden Framework is all about. Now, going into the Internet of Agriculture things or AG things, and if you look at the picture on the left-hand side, all of these, the tractors, the crushers, or the factories that are the windmill, all of these, if you clearly observe, it is all fitted with the wireless. So the intent is to say that, even at the crops here, on the farm, the crops here, there is a wireless signal display. The intent is to show that, you want to put your sensors which actually tracks and collects information, and on a timely basis it transmits that information to the receptors. I mean, through, of course, through satellites and technology and telecommunication and all that, and potentially it sends that information back to the data center, which captures all this information. Now, so that information pertains to something on the on-farm production, or it can even be about soil health, water content of the nutrients in the soil and things like that, and even the pest control, right? It can even tell you about how many, what is the percentage of pests and at what time you want to really apply pest control and all that, and also the ripeness of the crop, whether it is 100% ripe or it is yet to be done, and those kind of things, and even supply chain management that we talked about, like integrating the whole process, and transportation and storage, of course, the inventory and some of those, right? You really want to capture all this information and segregate them in a metrics called as timeliness, completeness, and accuracy. Timeliness is at what time of the day or the week that you're really capturing, are you getting all the information, right? And that is at a timely manner, you capture that. And you want to make sure whether you're receiving the data from all the all the sensors out here, which is the completeness, and how accurate is that data. So these kind of metrics and measurement that can be taken across, and just not within one farm, on the adjacent farms and adjacent crops and those things as well, that you can create and measurement. Right? Now, having taken all that information, what do? We put them into a system or an application called as a big data. Now, because this data's information is coming across from multiple sources, from lot and lot of other sources, right? And that's why it's called as a big data. And it can be in any form. It can be in a social media format, or in a text stream, or in an email, or in any of those. But just capturing the information alone is not enough. You really have to create and tangible value out of it, what is called as an actionable intelligence of that information. And that's what the value here is refers to. And to get the value of that information, you potentially use statistical methods, or the correlations, or the hypothetical scenarios and the events and all of those, and you apply your regression methods and analysis and those kind of things, or even uh, predictive analysis and those kind of information, right? And create a real value. And of course, the veracity, variety, velocity, and volume, these are all the different V's of big data. Now, to implement this, right, and of course, these are some of the opportunities that we see in terms of big data. Why you have to do this? Because it's an evidence-based tool, and which can be sustainable and long-standing, and it creates economic opportunities for farmers and the health of the consumers, right? So it's an open data forum. And also from an access point of view, it is open for research or to perform any meta-analysis, and also for publication of data. So in both the ways, right? And if you look at on the left-hand side here again, it is the government that needs to be actually supporting in terms of sharing that information, and also providing in free access. And that is where the Godan comes into picture. On the challenges, as we know, everything and anything comes with a set of challenges and issues, right? Especially is in terms of like who owns that really the information, right? And there are so many technology systems that we are developing, who has the ownership of these things, and all those comes into play. And also the decision support tools. At what point do you capture that information and say, hey, where the percentage of a pesticide or in pest control or the ripeness is what, this is what the measurement is supposed to be, right? So those kind of decision tools and or the decision making that needs to be held carefully. And of course, the cost, bandwidth, and quality, because of the volume of information that you capture in big data, these things always go hand in hand in terms of challenges. And also the connectivity, the security, and the storage of all that information, right? And so these are some of the key challenges in terms of when you implement big data. the ground realities. Now, especially in countries like India, which is yet to be developed, or where the technology advancements are not really accepted, some of them are like, some of the issues, like in terms of, oh, when you go and talk about data, what is it? What data are we talking about? And how reliable is that information? And is that really available? Or somebody has to actually start building that information, right? Including, like, in terms of, talk about in terms of farmers, and each farmer, how many acres or hectares that they own, even that government related information itself is currently not available, or even if it is available, but you're not sure how realistic it is and how reliable that data is, right? And also the policy hijack, right? Vested interest driven by vote bank concerns. Again, the politicians, and they politicize this so much, and also they oppose the modernization or mechanization, right? They really do not want to use any machines and those kind of things in farms, so which actually, again, these unions and those kind of things, they come into play, right? Beyond that, you also have intellectual property right related issues, and this is where the government again has to come into play and really fix those kind of IPR related stuff. And also the individual farmers versus collective farms and cooperatives. So most of the Indian farmers, anyone who's got like 100 acres of land, has to be noted with the government for sure. Of course, even with the below also though. But many of the farmers are like small size of the farms, like they only have like half acre to 1 acre, or maybe 1 to 5 acres of land. Now, if you really want to start implementing this kind of planting the bots or the Internet of Things and the sensors and those kind of things to collect the data and provide and transmit that information into any consulting organization, which is actually communicating back in a timely fashion to the farmer, saying, hey, today you don't sow these kind of seeds, or you don't put so much water today, there's already enough water content, and or on a later date you want to apply a particular pest to control the crop failures and things like that. So all of this timely information that you want to provide to the farmers, and the kind of investment and the setup that takes in to do that is pretty huge. And that can be really break even, or it can be worked out only if you're planting this kind of information bots or information capture related devices and those kind of things, where the crop or the farmlands are huge, right? So again, you want to do that on a cooperative societies, like bring in all the small farmers together who has their lands adjacent to together, make a cooperative society and start implementing on the society instead of individual farms. Okay. So some of these are potentially the ground realities for implementation of such an thing, of bringing benefits to the farmers, right? And definitely it will the precision farming methodology or the process is it's going to actually benefit the farmers if you are utilizing the crop inputs efficiently, like I just mentioned, and the spread of the sensors, right? And the spread of sensors that frees the farmers from the constraints of uncertain weather. So the sensors will be able to predict exactly and tell you, like when there is weather-related issues coming, or when there is going to have a heavy downpour, so they can start protecting in the farms or the yield or the produce and keep them in a safe haven. And so the utilization and selection of big data is advantageous and permits efficiencies regarding cost control, which we just discussed, profitability and advancement. Right. So the future research, it's all about to get through the obstacles using big data analytics, like some of the challenges that we discussed in agriculture for unveiling the proficiency from raw unstructured data. Right. So this is where the biggest challenges is to get the farmers, the government, and the technology, all of them integrated together to make the solution work. And I would actually say marketing is an art to really break the last barrier here, right? So that's where most of the issues are, and getting a buy-in from the farmers who are uneducated is the biggest challenge. So you need to certainly handle that kind of a situation. Okay. So thank you all. Thanks for listening on this video. Have a good day.